In this section, we'll write a script which will monitor a directory for file changes. Now, often it's important to monitor the changes in files in a given directory, or maybe even multiple directories on a system, to ensure quality of service, or to even check whether or not someone's broken into your system or is making unauthorized changes. Let's open a shell, and we'll be using, of course, everything that we've covered, nothing new. We'll open a shell. We'll navigate into our typical temp2 where the scripts are located. Now we'll create the script within this directory, but we'll move the script to a different directory to have it operate on the temp2 directory. So we don't want any output from our script to impact the numbers or the results returned by the differences that we'll be calculating. Let's make a script. We'll call this one filediff.sh, and within here we start off as usual, typical headers, have an end section, and we'll continue with the typical stuff. We'll give it a purpose line. This will monitor directories, or we'll say directory for file changes. We can always alter it to monitor multiple directories. So how do we go about monitoring a specific directory for the differences in files? Well, first and foremost, we should take a snapshot of the directory before we actually begin the monitoring process. So before writing anything else in the script, we'll open a new tab, Control-Shift-T, and we'll navigate to the directory that we're interested in. Now, we've worked primarily in temp2, so let's say we want to monitor this particular directory. This directory contains many files, but we need a snapshot. The quickest way to get a snapshot is to run the ls command, and by passing in the uppercase or capital A option and do a directory count. When you do an LSA, it returns the files, but we want to redirect the output of ls to a file because that'll serve as our snapshot. So let's LSA, and we'll send this to a file called FileList1. FileList1 will contain the files that are currently here. Now if we LSL tr, which shows us the last created item at the bottom, August 29th, FileList1, we can cat its contents to see what's included. We can also do a word count on it, which will count the lines for FileList1, and it has X number of items. So we'll be using FileList1 as a comparison. Now ideally you should move your snapshot file to a different directory, including the script that you'll ultimately save. It should be stored in totally separate directories, and in fact if this is going to be a system-wide script, you should put it somewhere else, such as in a shared location, such as user local. So let's make a directory in user local, and we'll call it FileDiff, and we'll place our output files, the snapshot file, and everything within user local FileDiff. So let's move FileList1 to user local FileDiff, and you can put this in any directory, but ideally you should keep any of the files that are associated with the script out of the directory that you're actually monitoring, so that you don't confuse or end up with wrong results. So we have our FileList1 file in user local FileDiff. We can LSL it to show you, and there it is. Now what we should do is proceed with modifying the script. We have a snapshot, and the snapshot can always be updated, overwritten, etc. We'll be comparing against this particular snapshot. We'll also ultimately save filediff.shell in the user local FileDiff directory. So filediff.shell will be able to find the snapshot file, which is called FileList1. So now how do we go about it? Now that we've taken a snapshot of the directory, which we can always update, we need to actually compare against the snapshot. Now there's a comparison utility called Diff available virtually on all Linux and Unix systems. So we'll be using the Diff command to do a difference between the original snapshot, or the first snapshot, and the current directory listing. And we can run that command, and ascertain the differences. We'll be also altering the command by cutting it. Now let's show you from the shell what happens when you run a diff. If you were to do a diff between file list 1 and the current directory listing, you'll see, for example, that there's a big difference. So if we were to store, we'll do an LSA here, and in terms of the output, that is, we'll LSA here, and we'll send the output to user local file diff, and we'll call it file list 2, because this is the snapshot after. We'll be comparing two files. So we're going to store results in two files and do a comparison. So now we have two files to compare. We can run diff against them. If we ls user local file diff, we have two files. Now, if we actually diff, let's actually navigate over to user local file diff so that we're within the directory. If we're to diff file list 1 and file list 2, you'll see if there are any differences, and it shows as a difference file list 1. You can ignore the first line. This we will cut out using a condition, and we also can ignore the first column, which contains a less than sign. That's not a problem. So when we've diffed file list 1 and file list 2, we came up with a difference of a file called file list 1. And that's because, of course, we sent the output to a file called file list 1. But if the files really changed on the system, then they would show up. But we're going to use diff, and we're also going to use the cut command. So we're going to pipe the output into cut. We want field number 2, because field number 2 contains the differences. Field number 1 contains a value to indicate to us visually that it is a difference. So we want field number 2, and the delimiter is, of course, white space. Now look at the output. The difference is much easier to deal with. We have two values returned. You can ignore the first always. This is maintained by diff, but we're going to use a condition to get rid of this first value. So now we actually have the difference. So our script is going to actually check on this and report on it for us as being the difference. Excellent. So now you know that what we're doing. Let's actually write it out in a script. We can set a variable. We can call it file diff. Let's call this variable file diff is equivalent to, and now we can use backticks to ascertain the value of the difference operation, which will take place at the prompt. So file diff is equivalent to diff, and we're going to diff the difference, or do the difference between file list 1. File list 1 is the original snapshot, and file list 2. Now file list 2 is not created here yet, but we're going to do it one step before. So let's show you that. We're going to do file diff between file list 1, file list 2, and we're going to send it to the cut command. We want field number 2, and the delimiter, as we've done before, is a white space. Then we end the command substitution. So we have a variable file diff. This variable file diff is important because the for loop will use it to loop through the values that are included. But we don't yet have the file list 2 file. So we actually need to create the file list 2 file every time we run this script. So that's something that we should do first. First and foremost, we need to run an LSA, capital A, to suppress the implied dot and double dots in the directory. We want to send that output into file list 2. File list 2 is the after snapshot. File list 1 is the before snapshot. File list 1 should be created outside of the realm of the script at a different point. So the administrator should manually create file list 1 as the acceptable list of files, and then every time the script runs, it'll create what's called file list 2. File list 2 will then be used to compare against file list 1. So we'll create file list 2, we'll do a diff, and now that we have this variable called file diff, we can actually, before getting fancy, just echo its output. So if we're to echo file diff, you'll see what comes up. So let's echo it, and we'll echo file diff, and then what we'll do is we'll create files in a given directory. Excellent. Now also, we should set some other variables. If we're going to run the script within the script directory, or we want it to actually operate on a different directory, such as temp2, we should specify so. So we should have yet another variable here called perhaps monitor directory. So we can call one monitor dir is equivalent to root, and this could be tilde expansion root temp2. This is the directory we're operating in. So that when we run the file differential using the LSA command, we can tell it operate on the monitor directory. So these scripts are going to run from user local file diff, but we want it to operate on the monitor directory. So we'll specify here monitor directory, and it'll operate on monitor directory, and it'll output the difference into our user local file diff as file list 2. And then of course we can do diff file list 1, file list 2. So diff is not actually going to operate on the directory. It's going to operate on two files. File list 1 before, file list 2 after, and then the script will echo for us what it thinks the differences are. Once we have that complete, we'll show you then how to suppress the output even further. So let's exit here, and we'll move this particular script file diff.sh over to user local file diff, and then we can actually work from that directory, because we're interested in monitoring, of course, the temp2 directory. We're currently in root temp2. Let's go to user local file diff. Now in here we have a few files. We have the actual shell script, which is currently not executable. We have the before snapshot, which was done at noon, and we have the after snapshot, which was done at 12:03. We can get rid of this after snapshot because we want this to be created each time, although the script will get rid of it for us, so we don't have to do this manually. But just to show you how we're going to start, we have two files, the script and the before snapshot. And if we can cat file diff.shell, you'll see what it'll do. It has a monitor directory. It's going to list the contents of monitor directory and send that output to file list 2. Then we have a variable file diff that's actually going to do a diff between 1 and 2, cut out the things we don't want, extract what we do want, and then echo the variable. Let's try it. We'll do file diff shell. Excellent. So now two values are returned. Now this may not look like much, but this is enough of a list. This is a list as far as a for loop is concerned. This is enough of a list for a for loop to navigate through. So now we need to finish this script. Let's pico file diff.sh. So now that we know that we're getting the right values, we know the differences, what do we want to do? Well, we can get rid of echoing this stuff here. Now we need some logic. We need to navigate through file diff. So for file in file diff do done. So we want the for loop to navigate through file diff because it's a list. And within we're going to nest a conditional. We're going to nest an if. Now we're going to say we're going to do a test because we want to suppress that first line of output returned by diff if the file actually exists. So if existence file, then we're allowed to operate, and then we end it. Then we want to actually echo file. This is a good way to clean it up. So what the if logic does for us is it checks to see whether or not the first line of output outputted by diff is actually a file on the file system. If not, it ignores it. So we'll only get row number 2 and other files, real files. Now let's run this again and see what it looks like. Now you see we have two files, file list 1, file list 2, but it'll get overwritten. Let's note the date, it's 12/11, almost 12/12. The new file list 2 file will be called file list 2, but with a date of 12/12. Let's source file diff. Now as you can see, what's returned is truly the difference. File list 1. Excellent. That is the actual difference in our root temp directory. Let's jump tabs over here and we'll go to our home directory temp2. If we do an lsltr, you'll see all of the files that exist within this directory. So there you have it. It's actually finding the difference for us in that directory. It's doing a diff between file list 1 and file list 2. File list 1 contains, of course, the old snapshot. Now let's remove file list 1 and 2. So we'll remove RF, file list 1, or file list star. Now we just have the script. So if we wanted, we can do a snapshot yet again, an initial snapshot. Let's do an LSA of root, or tilde expansion because we're logged in as root, temp2. and send it to a file called FileList1. Now we have a new snapshot. If we were to rerun this script, FileDiff.shell, you can see there are no differences. There are currently no differences. So now we could actually have this script set up in the cron tab to keep running, let's say every hour or so, or maybe once a day, and it'll just keep running and returning no output. Now let's prove that the script actually finds the newly created file. We'll jump Windows over here to Temp2. Let's touch a new file. We'll touch a file. We'll call it testing file diff monitor script. This is a new file. 0 bytes, but it's still a new file. Now let's see if FileDiff catches it. Now in this case, FileDiff doesn't catch it, and that's because there's one thing missing from the script which we need to show you. Let's modify FileDiff.sh. When we run the if condition logic here in this section to see whether or not the file actually exists, the if logic is performing its tests based on the current directory. So what we need to tell it is actually a prefix of monitor directory file name. So it should be prefixed with monitor directory. Otherwise it doesn't know. So if we told it, for example, monitor dir, which is a global, monitor dir, which is a global directory, a global variable within this particular script for that directory, then it'll actually check /root/temp2/filename. Now let's try that again. We'll return to the prompt, we'll source it, and as you can see, it detects the new file, testing file diff monitor script. Let's jump directories here. Let's touch a different file. We'll just add an extension such as 2, and let's rerun the script and let's see if it picks it up. Now it finds both files. It knows that both are different. And anything you do to this directory will be caught. Let's make 3, and we can use brace expansion here to perhaps make 4, 5, 6, 7, 8, 9. That has created files 4 through 9. And if we run the script, it all comes back. Testing file all the way up through 9 are newly created files within that directory. So once again, you can use the cron facility to report or to run the script on an interval basis. And then within FileDiff, we can actually say, well, if there's a difference, other than echo the difference, do something about it. Perhaps send the output to a log. If you simply ran this script as we've done here and redirect the output to a log file, then it would get stored in a log file. Let's call this file, for example, FileDiff.log. If you want, you can use command substitution, that is, to get the date in the output or in the name of the file. So the output of the date command will be embedded in the file name. We give it a %f, and this will create a nice log file for us, and the output will be stored within this directory. So we've separated the script. It's 2 files that it'll operate on. The FileList1 is a before snapshot. FileList2 gets created at the time of operation. And then here's a log. If we cat FileDiff.log, you'll see there are the differences. We could even put the date in it, but the file name says it all. So that's a simple way to monitor a directory to see if anything has changed. You don't really need anything fancy or commercial software. Just set up the directory you want to monitor, actually list the contents to a file so that Diff can do a comparison. And there are other ways to do this, but this is a simple way. And you're not actually putting the contents of the file in your file that you're testing. You're simply just putting the names of the file. Set up a variable with command substitution which actually performs the difference. Cut out the junk, the unnecessary junk in the file. Run a for loop on the actual returned values. Have a condition check to see if the file actually exists, and then echo the name of that file. We're echoing it, but you could also mail it or send the output somewhere or do something else. So this is a simple file differential script. It can be altered to monitor many directories. For example, you could change the variable that sets up the monitor directory to be driven, for example, from the command line using positional parameters, and it would work as well. So there you have it. Simple script, checks the directory for changes. This can be used in any environment for security to see whether or not a directory has changed, or just to keep tabs on a directory that's important. Perhaps should only have 20 files, but If there's another file added, there's a problem, etc.